Hi, boys and girls. This is the instructional video for section 4.3, Symbols and Slope. Yes, we are not done with slope yet. We still have many slope adventures. We're going to be talking about similar triangles, and I just want to kind of review a concept that you've probably already learned. Similar versus congruent. When you have items that are similar, that means they have the same shape, but not necessarily the same size. Congruent objects have the exact same size and shape, okay? Notice these little signs here. Congruent means they're equal to each other, okay? Same shape, same size, everything. This is the symbol for similar, and that means they have the same shape, but they can be different sizes, okay? So we're starting in your workbooks on page 205. We're talking about similar triangles and slope. Your I can statement is, I can identify similar triangles that fall on the same line in a coordinate plane and show that the slopes of the lines are equal. The vocabulary you will learn: corresponding parts, similar figures, and slope triangles. Okay. So, when figures have the same shape, but not necessarily the same size, they are called similar figures. Similar figures have corresponding parts. Okay, what that means is that they have corresponding angles and sides. Okay, these two triangles are similar. They're the exact same shape, but they're different sizes. Now, they have corresponding angles. Like, for example, angle C corresponds to angle Z. Those two angles will have the exact same measurement. Angle B corresponds with angle Y. They will have the exact same measurement. The sides, however, are proportional, okay? The lengths of the sides will be proportional. Notice that this 3 gets doubled here, this 5 is doubled here, and this 4 is doubled here. If one side is double, all the sides are double. That's what proportional means, okay? So if two triangles are similar, then their corresponding angles are congruent or equal in size, and their corresponding sides are proportional. Triangle ABC and BDE are both right triangles, and they fall on the same line on the coordinate plane. These right triangles are called slope triangles. Slope triangles are similar, so their corresponding sides are proportional. Okay, because they were drawn on the same line, they're slope triangles. The vertical and horizontal sides of the slope triangles are the same as the rise and the run of the line. You can use the properties of similar triangles to show the ratios of the rise to the run for each triangle are equal. All right, so that's a lot of math words, but here's what it says. It says the slope of this line is rise over run, which you already knew from last chapter, okay? But they're showing you here corresponding sides are proportional. So that means, and they don't have the line. When you learn proportion, you learned it as little fractions, and they're missing their lines here. It's a formatting error. There should be a line there, and there should be a line there. They're proportional, okay? So what if this is, 2 and 4, and then you double it, this would be 4 and 8. They're going to be proportional. They're being multiplied by the same number. And then there's a bunch of math gobbledygook, but here we get down to some real numbers, okay? Substitute the rise and the run for each slope triangle. Okay, well, on this big guy here, the rise is 6. We move up 6 blocks. 1, 2, 3, 4, 5, 6. So the rise is 6. The run is 1, 2, 3. Okay, there's your run. This is going to be challenging for me because I'm being asked to draw lines. On the little guy, your rise, 1, 2, 3, 4, is 4, and your run is 2. So what they're having you do is simplify. You would reduce 6 over 3. 6 over 3, you divide both by 3, and get 2 over 1. So since the ratios AC to BC and B... talk much? Okay, you read that. Those letters are equal. The slope is the same anywhere on the line. Well, obviously the slope is the same. It's the same line. The slope has to be the same. Okay? All right, the ratio of the rise to the run of two sloped triangles formed by a line is equal to the slope of the line. Okay, so the larger triangle, we're talking this guy here, has a rise of -6, all right? Because traveling from left to right, we have to go down. We go down 6, so the top number is -6. Then we go right 3, so the bottom number is +3, okay? Or that reduces to -2. The smaller triangle, this little guy right here, goes down 2. We're going from this point right here to this point right here, okay? We go down 2 and right 1. So, so they've got down 2, right 1, and that reduces also to -2. So the slope of the line is -2. Okay, and that's the slope is the same for this triangle as it is for this triangle. Now the segment is shorter in this one than it is in this one, but the slope stays the same. All right, the video that is a McGraw-Hill video, I'm going to try to assign that to you. I haven't done it yet. I'll try to assign it and see if I can get it so you can watch it. The video shows how to use sloped triangles ABC and CDE to find the slope of the line. Okay. So we have AB and BC. Let's see. AB is up 1, 2, 3, 4. So from A to B, we go up 4. And BC is right 3. And then they filled in CD for us. This is up 8 and right 6. All right. So if you were to reduce this, notice if you divide top and bottom by 2, what do you get? 4/3. Both of these have a slope of 4/3. This line has a slope of 4/3. Okay, example 1. Compare slopes of similar triangles. The graph of line T is shown. Use the similar slope triangles to compare the slope of segment AC and the slope of segment CE. Find the slope of segment AC. Use triangle ABC to find the ratio of the rise to the run. Okay, so from A to B is up 3, and B to C is right 2. So the slope of the segment is 3/2. Find the slope of segment CE. That's this line segment right here, in between C and E. They want to know the slope of this segment. Okay. Well, of course, it's going to be the same as this segment, obviously, but they want you to find it. So from C to D, we go up 1, 2, 3, 4, 5, 6, up 6. And then we went right 1, 2, 3, 4. And if we reduce that, we get 3/2, which was the same. Okay. This is really a very easy section. I'm glad this one fell on this week because it's a short week. And last week was a difficult week, so I think that you'll enjoy this and get it right, and it'll be fun. The graph of line D is shown. Use the similar slope triangles to compare the slope of segment FJ and the slope of segment JK. Okay, so they want the slope of FJ. That's this one right here. And they want us to compare that to the slope of JK, which is this one right here, right? Well, to go from F to J, all right, we're doing rise over run, just like we did in the last section. Okay, so for this big triangle, we start here, we go down 1, 2, 3, 4. Down 4, right 2. Always reduce your slopes, and if it reduces to a whole number, go all the way to a whole number. Okay, so the slope of this line is -2. Would slope dude agree that that's a nice negative? Heck yeah, he would. Okay, what about the slope of JK? All right, while traveling from J to K, we have to go down 2, so the top number is -2, and right 1, which is +1. Which also reduces to -2, right? So we're comparing the slope of this one to the slope of this one. They're exactly the same, which is what we expected. Verify slopes using slope triangles, okay? The pitch of a roof refers to the slope of the roof line. So when you say pitch of the roof, they're saying it's basically the slope of the roof. Choose 2 points on the roof and find the pitch of the roof shown. Then verify that the pitch is the same by choosing a different set of points. All right, it looks like they've already chosen the points for us. They've chosen R and S, and they've chosen U and T, okay? So use points T and U to draw a slope triangle TUB. It's already there. See, it's already there. Okay, so we're doing the slope of this segment here. So we're going from left to right, okay? So that's, and they've drawn the triangle down here. I would have drawn the triangle up here because I want to go up first. So I go up 1, positive 1, and right 2, positive 2. So the slope of that part of the line is 1/2. Let's see, it says the pitch of the roof is 1/2. Verify that the pitch is the same using 2 other points, S and R, okay? Well, from S to R, we'd have a triangle that looks like this. It would be up 2, and right 1, 2, 3, 4, right 4. This also reduces to 1/2, and since slope is 1/2, the pitch is the same. It's kind of like, common sense. If it's a straight line, the slope is the same along the whole line. If you find the slope of one of these triangles, you've got the slope of the other one. It's a little redundant, but I can't resist a section on triangles. All right, the plans for a skateboard ramp are shown. Use 2 points to determine the slope of the ramp. Then verify that the slope is the same by choosing a different set of points. Okay, so let's see. If we're going to do the slope from G to H, let's choose these points for starters. We're traveling from G to, oh wait, I don't want to go that way. When we go from G to H, we would go this way and this way. We always want to do up or down first. Oh, that's a terrible line. Oh, that's so bad. I bet I can do better. Let me see if I can do better. Try really hard to be super careful. Oh, it's a little crooked. Okay, so we're going to use this right triangle here from G to H to find the slope of this line. Well, starting from G, remember we do rise over run. Starting from G, we go down 2, so that would be -2. And then we go right 1, 2, 3, 4, 5 spaces. And right 5 is +5, so the slope of this segment is -2/5. Now let's do a different color. Let's do the slope from J to K. How about that? We'll use this triangle right here. It's already drawn for us. I can't screw it up. To go from J to K, we go down 2 and right 1, 2, 3, 4, 5. And that means the slope of that part of the line is also -2/5. In fact, the whole line is -2/5. Let's say, for example, I use this whole big honking triangle, okay? I go from G all the way to K. What would that look like? Well, I would go down 1, 2, 3, 4, 5, 6. I would go down 6, and I would go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then I would reduce this by dividing top and bottom by 3, and I would get -2/5, which is what I got for all of the other parts. The thing is, if you use the bigger triangle, you'll have to reduce your slope. Use the smallest triangle, you won't have to reduce. So if you don't like to reduce, go for the little triangle. I went easy on the secret word today because I really don't have time. You guys have been flooding me with emails today. So the secret word is purple. It's actually my favorite color. You might think green is because I love frogs, but if I'm going to buy, like a jacket or something, I'm going to go for the purple one. So, yeah, my favorite color is purple. And that's all there is for this video. Not bad, only 14 minutes. All right. Well, we'll see you on the practice problem video. Have a great day.